Are we humans truly alone in this immense universe? Or does intelligent life exist somewhere beyond our planet? If aliens are real, it's only natural to wonder if they too ask themselves a similar question. Are we alone in this universe? How could communication between two intelligent species in the cosmos ever be established? With this thought in mind, NASA embarked on several projects to send messages to potential alien civilizations. One of these began in 1977 when NASA launched the Voyager 1 spacecraft with a clear mission to explore the solar system from the outer planets to the farthest reaches of the sun's influence and perhaps even beyond. Simply put, this was an interstellar mission. Our galaxy, the Milky Way, contains billions of solar systems, and the vast regions between them are known as interstellar space. To date, only two spacecraft, Voyager 1 and Voyager 2, have successfully crossed into this realm. Leaving the solar system is an extraordinary achievement, requiring vast amounts of time, yet these two spacecraft managed it, making them truly exceptional. Voyager 1 in particular has traveled so far that it is now the most distant man-made object from Earth. As of January 2025, it lies 24.9 billion kilometers away from our planet. What makes the Voyager missions even more fascinating is that they carry messages intended for alien civilizations, an effort to tell them about humanity. These spacecraft are venturing into the immense void beyond our solar system in the hope that if intelligent extraterrestrial life is ever encountered, these messages will serve as an introduction to our species. But what do these messages contain? What do they say about us? In today's video, we'll dive into the full story of the Voyager missions. The tale begins in 1965 when a NASA engineer noticed a rare alignment of the solar system's outer planets, Jupiter, Saturn, Uranus, and Neptune. This unique event, occurring once every 175 years, provided a remarkable opportunity. It meant that a spacecraft could use the gravitational pull of these planets to perform flybys of all four with minimal fuel and time. This technique, called gravity assist, uses the mass of a planet to alter the speed and direction of a spacecraft. NASA based the Voyager 1 and Voyager 2 missions on this principle, selecting 1977 as the launch window to take advantage of this rare planetary alignment. Voyager 1 was tasked with flybys of Jupiter and Saturn, with a particular focus on Saturn's largest moon, Titan. Meanwhile, Voyager 2's mission included flybys of Jupiter, Saturn, Uranus, and Neptune. The two spacecraft were designed similarly, powered by three radioisotope thermoelectric generators, RTGs. They lacked solar panels, as solar power becomes ineffective beyond Mars and Jupiter. Instead, the RTGs converted the heat generated by plutonium's radioactive decay into electricity, ensuring they could sustain themselves throughout their extended journeys. Both Voyagers carried 10 scientific instruments, including imaging systems for photography, spectrometers to detect ultraviolet and hydrogen activity, magnetometers to measure magnetic fields, high-gain antennas for communication with Earth, and other instruments to measure radiation levels. Voyager 2 launched first on August 20th, 1977, followed by Voyager 1 on September 5th, 1977. Despite its later launch, Voyager 1 took a faster, more direct route and reached Jupiter first. In March 1979, it captured breathtaking time-lapse images of Jupiter, showcasing its rotation and its faint ring system, discovered for the first time. Voyager 1 also observed active volcanic activity on Io, one of Jupiter's moons, the first instance of volcanoes being detected on another celestial body. Before this mission, it was believed Jupiter had 13 moons, but Voyager 1 discovered two more. A few months later, on July 9th, 1979, Voyager 2 reached Jupiter and identified yet another moon, increasing Jupiter's known count to 16. Today, we know that Jupiter is orbited by 95 moons. In November 1980, Voyager 1 arrived at Saturn, capturing stunning images and identifying three new moons, Atlas, Prometheus, and Pandora. Intriguingly, Pandora shares its name with the alien planet in the movie Avatar, though in reality, it's one of Saturn's moons. Saturn's largest moon, Titan, held particular interest. With potential evidence of liquid water, Titan became a possible candidate for alien life and a frequent setting for science fiction. After Saturn, the Voyager's paths diverged. Voyager 2 ventured toward Uranus and Neptune, becoming the only man-made object to visit these planets in 1986 and 1989, respectively, sending back incredible images of these distant worlds. Voyager 1, on the other hand, veered out of the ecliptic plane, the flat plane where most planets orbit the Sun, gaining tremendous speed through gravity assists. Today, Voyager 1 is traveling through interstellar space at a speed of over 60,000 kilometers per hour. power. This diagram shows the approximate positions of Voyager 1 and Voyager 2 as of 2025. On February 14, 1990, Voyager 1 captured the iconic pale blue dot photograph from 6 billion kilometers away, showing Earth as a tiny blue speck. It also created a family portrait of the inner solar system, capturing Venus, Earth, Jupiter, Saturn, Uranus, and Neptune. Mercury and Mars were either too faint or obscured by the sun's glare, while Pluto, no longer classified as a planet, was too small to be visible. After these historic photographs, Voyager 1's cameras were switched off to conserve power and memory. In 1998, Voyager 1 officially became the farthest human-made object from Earth. By 2004, it had crossed the termination shock, the region at the solar system's edge where solar winds slow down significantly. In August 2012, Voyager 1 exited the heliosphere, the sun's protective bubble, and entered interstellar space, marking humanity's first venture into the vast, unexplored void beyond. NASA confirmed this historic achievement in September 2013 after extensive data analysis.